there, class. Today we're going to do section 6.2. So I've got some starter problems. To pause the video, go ahead and get started on writing the notes. And I put one up here for you guys to try pretty much right away so that we can build our skills. And I think you'll do okay with this after you see me work out the first two. So this goes back to your K-12 knowledge. At some point in time, you took a math class in which you were asked to multiply fractions. And for many of us, that was the point where math went from being like, math is fun, to math is really challenging and difficult. And when we started to introduce operations with fractions, for students who don't really think analytically and mathematically, and that is a challenge, oftentimes it comes straight back to the whatever grade you were in where you first learned about fractions. So let's take it back to that point in time and try to recall how we multiply two fractions. And so you may remember a method from your past called cross-canceling, meaning that we can reduce by any common factors. And so when we cross-cancel, we can cross it diagonally, or you can also reduce your fraction between the numerator and the denominator. So you're allowed to go top to bottom, and you're allowed to go diagonally. You don't want to cross out any common factors between the two numerators or the two denominators. You're not allowed to go that direction. So basically, we're just taking out any common factors. And if you need more examples, your book will lay that all out for you as well. So for instance, between 18 and 20, both of those numbers are even, and you can reduce both of them by a factor of 2. So 2 goes into 18 9 times, and 2 goes into 20 10 times. And I'm going to make this really colorful here today, and I'm going to look now and say, gosh, are there any common factors that I can do from any numerator and denominator, even if it's diagonal? And I see this 15 and I see that 10, and I think to myself, gosh, both of those numbers are divisible by 5. They have that common factor of 5. 5 goes into 15 3 times, and 5 goes into 10 twice. And then what we do is we just kind of double check. We have a 9 and a 3. Now we can't cross anything out there because they're both in the numerator. 2, 3, nothing else can be reduced. We have no more common factors. And so what we do when we are left is we multiply top to top, and we multiply bottom to bottom, or numerators multiply and denominators multiply, and that is our final answer. So this is the idea behind today's lesson, just taken to a more complicated level. So let's introduce some variables here. Nothing has changed other than the fact that I have some letters in the mix. So I can divide out top to bottom, and I can also work it diagonally. So for instance, 2 goes into 16 8 times. 2 goes into itself once. I have x squared on top and x to the 4th on the bottom. So if I extend this, just to kind of refresh your memory, if I expand, not extend, if I expand that, that would be x times x, and x to the 4th is that. So 2 of these are going to cross out with 2 of those, and I'm going to end up with x squared in the denominator here. All right, if you remembered that rule where 2 of these just subtract, same thing. 5 divides into itself once. 5 divides into 15 3 times. And I guess kind of look over, there's nothing else that I can reduce. So what am I left with? Well, I'm left with 8 times 3, which is 24. I'm left with a 1 here and a 1 there, so 1 times 1 is 1, but I've also got this x squared, or this x times x, which is x squared, written there. Okay, don't include both, obviously. I just was illustrating. All right, so this is my final answer here. Go ahead and try this one on your own. There is one little trick. See if you can figure it out. Okay, so this has A's in 2 different spots, so that was the trick. If you cancel this A with one of those, then you're down to A to the first power in the numerator. So one of these subtract into those 3 and we end up with A squared. My way is not the only way. As long as your final answer has A squared in the denominator, you did it correctly. What about the coefficients? Well, 3 goes into 18 6 times. And once again, both of these are in the numerator, so you don't reduce them, you multiply them. So 6 times 2 is 12. And A squared, and there's nothing left there. You can write the 1 if you want in your notes. My guess is when you enter your answers on My Math Lab, you're not going to include that 1. All right, so this is the gist. Let's up the level of difficulty just a little. You hear in the background I have a pug, and all pets in America all pets globally are being spoiled in many cases right now. And my pug is no exception to that rule. So no one's in the family room currently, and she does not like that. Her name is Mabel. Mabel is going to be 3 in like Thanksgiving time-ish. So just barely coming out of her puppy tendencies. And she's headed over here. I built some gates a few summers back to keep her constrained because I didn't want dog hair in my bedroom. So she has the outside and the kitchen and the family room to roam around in. All right, I'm ready to go. Enough babbling. So now maybe you're like, oh my gosh, that's really a bigger level of difficulty. Don't freak out. Again, think about the suggestions I've given you in the past. Maybe cover up one of the fractions so that it doesn't seem so impossibly complex. What you're gonna do is you're gonna factor each piece. So instead of factoring being like the whole problem, now you have to factor 4 times in just one problem before you're able to cross out any common factors. So if you need to go back and rewatch any of those factoring videos, in an in-person setting, I would definitely emphasize every day, 10 times a day. Factoring is our #1 skill in the class, and there's just not a time where we don't circle back to factoring in every chapter moving forward. So here we go. What am I going to take out of 10x plus 20? There's a GCF of 10, and that's going to leave me with x plus 2. What am I going to take out of x squared minus 1? Well, that is the difference of 2 perfect squares, so it's x plus 1, x minus 1. What am I going to factor 5x plus 10? There's a GCF there. And then I've got this, which that's going to use that slip and slide method. So let's just come over here off. You can just work it off to the side on your scratch paper. We're going to multiply here. 2 numbers that multiply to 2 and add up to -3 need to be x minus 2 and x minus 1. If I multiply by that 2 in step 1, I need to divide by that 2 right there. This reduces to x minus 1, and this doesn't reduce, so that 2 slides in right there. So this one becomes x minus 1 and 2x minus 1. So that is all in step 1, and the quicker you are with factoring, then the less work it appears to be. So that is the reality there. And now we just look for common factors. So we have a pair of x minus 1s. So anything top to bottom or diagonal is fair game to cross out. So I actually think this part, I mean, it's not Friday night fun, but as far as math goes, I like crossing things out and making the answer more simple. Your x plus 2s, cross out. 5 goes into 10 2 times, and that's all that I can do. So let's write what's left. This stays in the numerator. This stays in, everything stays where it is. If it starts in the numerator, it stays there. If it's in the denominator, it stays there. And this is the final answer. There's not a need to remultiply there unless MyMathLab requires you to do that. But there wouldn't be a need for my purposes. You wouldn't expect to remultiply. All right, let's do it again. That's basically as hard as it can get. So there's different types of factoring that I can throw out at you. We can do any of the types we learned in chapter 5. So I just have a bunch more examples similar to that. Here's another one. Let's do t plus 2 over t squared minus 5t plus 6. And then t squared plus 4t plus 4. So I gave us a break on this one because I just wanted to show you that if it comes to you like that, not as a fraction, you can go ahead and create that fraction by putting it over a 1. So that's an option. This also helps to review how 6 can be a tricky thing to factor, and this one has a piece that is unique as well. So t plus 2 doesn't really do anything. But we need two numbers that multiply to a positive 6 and add up to a negative 5. And sometimes people go, oh, well, it's negative 6 and positive 1, which is great. Yeah, that does make negative 5. You've got a minus 6t and a plus 1t. But when you go to multiply those two, you end up with a negative 6. So that is right out. And if you don't factor correctly, then you can't cancel correctly. So we need to use the other option, which is negative 2 and negative 3. And then on the bottom here, we're going to have t plus 2 and t plus 2. Or t plus 2 quantity squared, but I prefer, you'll see why, I prefer in just a second to write it out twice. Two numbers that multiply to 4 that add to 4. So the reason I like to expand that is that way you can see a little bit better that you still have one of those left. Only one of those cancel. Then I also want to note that this is a positive 2 and that's a negative 2. And so some students might think, oh, close enough. It doesn't work like that. So sometimes not that many things cancel. And I think that as a student, it kind of kills your confidence because you feel like, oh, more things should cancel, so therefore I factored it wrong. And sometimes that's just not the case. Sometimes lots of factors cancel, other times very few will cancel. So every problem is unique, and this is our final answer here. I've got one for you to try if you're ready. Well, ready or not, you can, I'm going to throw it up there and you can try it, or you can just watch me. So m minus 2 is already there's nothing you can do. So I tried to be kind. And so there you go. And as you can see, I'm working off my old spiral here. So these are the exact same examples that I would be showing if we were in an in-person setting. So the level of difficulty is pretty much exactly the same. It matches the book. Some of these questions come straight from the book. All right, maybe you fast forward my babbling there. Let's go ahead and factor. So right here, I just have a GCF. Two numbers that multiply to 9 and add up to 6 are m plus 3, m plus 3. And then this one has kind of a trick. So I'll show you over here, because it has a GCF. So pull that 2 out front. And then this part inside the parentheses still can be factored. We have the difference of two perfect squares. We don't have that middle term. And so I am going to write 2m plus 2m minus 2. And then it does feel really good when things do cross out, because it kind of fills you with a little bit of confidence. You can throw parentheses around that if it makes you feel better. Those cancel, and these cancel. So what are we going to do? As I notice, I'm about ready to write our final answer. What are we going to do with those? We are going to multiply those. So you don't have to FOIL like binomial factors, but you are going to remultiply those two things when you write your final answer. So I would say it's m plus 3 in the numerator, and 3 times 2 is 6, and then m plus 2 in the denominator. All right, hopefully you found success. All right, so I'm 20 minutes in, and I'm gonna try one here off the top of my head because I forgot to write it down in advance. But I do, this is one that comes up often. Let's do m squared minus 4. Sorry, didn't really decide on a letter there, so that wasn't so great. And then m squared plus 2m plus 4. And then this is going to be m to the 3rd power minus 8. Yes, that'll all work out great. Okay, so hopefully this will all work out great. Top left, we're going to do m plus 2, m minus 2. I gave us this as a 1. Okay, here's the part that stumps students. This cannot be factored. So every once in a while, you're going to find some type of trinomial or an expression that cannot be factored. So let's just rewrite it. And something, I don't know for sure if you will end up with this one on your homework or not. And then here we have the difference of perfect cubes. So we need to go back. I apologize. Somebody must be walking around. I have an open backyard. Plus AB plus B squared. There is our formula there for the difference of perfect cubes. So I think this is lesson 5.5. If you go back and revisit that lesson, the idea here is what is being cubed? Well, m is going to be the a, and then 2 cubed is 8. So when we go to factor that, we get that piece right there. And so this just is that. And so now, if you take a second glance at your problem, this whole thing is that whole thing. And that will cancel. And then this cancels with this. And so that's why I wanted to show you. And that takes care of that, and your final answer is m plus 2. All right. There is only one section left here, and I have to kind of choose whether I'm going to go address my barking dog or whether I'm going to kind of plow forward with our video. I only have 2 left, so please forgive. I think I'll just go ahead and plow forward. The only thing we haven't addressed is divide, because I'm not quite sure how much you're hearing the barking dog. I definitely hear it. And when you have divide, you are going to flip the second fraction, just the second one, and change it to multiply. That's it. And then it's the exact same problem. So here's our example. Anytime you divide 2 fractions, flip the second one and change it to multiply. Now, the mathematical term is not flip. The mathematical term is write the reciprocal. So when you change the denominator and the numerator, and you go like that and you write it in reverse, it is the reciprocal. So if we take a problem that looks like this, and this is a divide right here, you are going to keep that first fraction the same. And the second fraction you're going to flip upside down. So the x plus 2 ends up in the top, and the x plus 1 ends up in the denominator, and that divide changes to a multiply. If you're already noticing that a problem comes with a divide, when you're writing it in your notebook, go ahead and reverse it, do the reciprocal when you write it down the first time, and that'll help save you an entire step of copying, potential mistakes, and things like that. All right, so now let's factor this. This top left factors to x minus 3x plus 1. This factors to x plus 2x minus 2. And then this is x plus 2. And this is x plus 1. And so these cancel. And these cancel. And once again, your only factors left are an x minus 3 in the numerator and an x minus 2 in the denominator. I've tried to keep our numbers really small here, tried to keep the factoring not too crazy, so I feel like 2's and 3's keep ending up in our answer. All right, last problem. Feel free to try it if you'd like. It does have just one little thing that's different that I want to point out. So example, try, it can go either way. Let's do a squared plus 3a plus 2 over a squared plus 4, and then divided by 5a squared plus 10a. So let's say you approach a problem that looks like that. Well, once again, this isn't written as a fraction, but you can write it as a fraction. And so then when you write the reciprocal and change this to a multiplication sign, the 1 simply ends up on top. So this is going to become 1 over 5a squared plus 10a. And as I write it, another option for you, because I know these can be really long, so you don't have to shortcut anything, but one option might be to factor when you rewrite it. So this guy is going to be a plus 1, a plus 2. A squared plus 4, that was a trick. A squared plus 4 cannot be factored. And then when you flip this upside down, the 1 ends up in the numerator. And right there, you have a GCF of 5a. So you have a plus 2 here. So just a couple things that I could remind you about with this one, how a squared plus 4 doesn't factor. And the only thing that cancels is that. And so this is our final answer. I always like to rewrite it just so that it looks nice and neat. I always use parentheses just to remind myself that I can't cancel the A's or anything like that. And so that is the entirety of the lesson. The problems are going to be different types of factoring, but the steps remain exactly the same. So good luck, and as always, reach out with your questions. Thank you.